Hello, I'm Wei Ming from the University of Toronto. I'd like to present our study, HiCu, Leveraging Hierarchy for Curriculum Learning in Automated ICD Coding. Automated ICD coding aims to assign ICD codes based on the discharge summaries after the patient is discharged from a medical institution. This is useful for purposes such as medical research, epidemiological studies, and billing. In machine learning, this task has been modeled as a multi-label classification problem, where we train multiple binary classifiers to predict the probability of assigning an ICD code to a discharge summary. Existing research on automated ICD coding commonly uses an encoder-decoder architecture. Given an input discharge summary, the encoder first extracts text representations, and the decoder performs a per-label attention operation and classification. A major problem of these ICD coding models is that they often regard ICD codes as flat labels and predicts each ICD code separately. On the other hand, the ICD system defines diseases in a coarse-to-fine manner, which can be represented by a tree structure. As shown in the figure, sibling codes under the same parent code will represent similar diseases compared with the codes that are under different parent codes. Our work aims to use this tree structure as the ingredient of a curriculum learning algorithm to enhance the performance of ICD coding. We first generate a label tree based on the output set of ICD codes, where the intermediate labels in this label tree follows the natural hierarchy of the ICD system. Our hypothesis is that this highly structured output space can guide the design of our curriculum learning algorithm, as it reflects the hardness of the learning problem at different levels. We then let the model sequentially predict the labels at each level of the label tree and transfer the learned attention weights in the decoder using our knowledge transfer mechanism, as shown by this animation. During training, we also introduced the hyperbolic embeddings of the ICD codes to further guide the attention computation, which we call the hyperbolic correction mechanism. By applying our method, we find that HiCu improves ICD coding performance over different encoder neural architectures. We observe consistent performance improvement for different metrics such as the AOC, F1, and precision at K after applying HiCu. We also observe that HiCu's improvements are most visible among rare codes. This figure shows that HiCu provides a larger AOC increase when the code frequency in the dataset is less than 5, which indicates that gains in AOC scores at rare labels are emphasized. We believe this is because HiCu's curriculum learning strategy reduces the difficulty of classifying these rare labels in the final training round. In summary, HiCu is a learning algorithm for multi-label classification problems over hierarchical label structures. Our paper studies the practical problem of ICD coding and finds that HiCu provides model performance improvement over different neural architectures, especially among rare codes. Finally, we believe HiCu can be applied to other multi-label classification problems within or outside healthcare, such as the OncoTree tumor type classification, ImageNet object recognition, and etc. Thank you.